In our previous video, we talked about a tool we can use and a way we can look at data, use something called the Simpson's Diversity Index. And what the Simpson's Diversity Index said was you can go to an area and figure out how rich or how biodiverse an area is by looking at and counting the different species that live there. But the question is, how do you count them all? Like, do you go to the rainforest in Costa Rica and count every single sloth? Like, that would be impossible, right? So we use a technique called quadrat sampling. And the thing about quadrat sampling is that it needs to be random. And we're going to look at how to generate the randomness of that. So when you've determined your area, usually you block off a certain area. It could be like 100 meters by 100 meters. It could be 10 meters by 10 meters. This has it by 1 meter by 1 meter, which seems quite small. I don't know if this is an example of maybe you're looking at a very small patch of grass. And so I'm going to change this just for argument's sake to 10 meters by 10 meters. So let's say this is the area you were looking at. So maybe it's part of a football pitch or whatever. And what you do is you drop a small square frame. I've seen them made out of wire, metal, PVC piping. And you drop them down randomly and you count the species there. So let's pretend we dropped the quadrat here. And I've seen students do different things. Like these two small ones are definitely in that box. But when you have something that's partially in the box, I've seen students make a rule that more than 50% of the plant or organism has to be in there to be counted. I've also seen students put in a fraction of the plant. So maybe you decide this is 0.2. So you could do that as well. So when we number our quadrats, or we identify which coordinate that is, we number these boxes 1 through, in this example, it's 10. 1 through 10 on the x-axis, and you do the same for the y-axis. So 1, 2, and then all the way up to 10. So this quadrat box, the coordinates of it would be 4, 1, 2, 3, 4, 5, 7. So that would be 4, comma 7. And then you would create a data table and you would tally the number of species you found. So maybe these little tiny green things are little types of grass. So that's a G. So in your table, you would put 2 grasses there. Okay, but I didn't randomly do that. I just chose a box. You can't just choose it because you like that box. So to make it random, to generate random samples, there's a couple different things you can do. So I've seen students in their IA use playing cards. So the ace is 1 and then 2 through 10. So you just randomly pick these numbers. So that's one way to do it. You got to make sure that you put those cards back, otherwise it's not random anymore. The other thing you do, you can go, oh my goodness, I'm in trouble talking. The other thing you can do is go to something called random.org, and random.org just generates quadrats for you randomly. So you just ask, or you just input how many quadrats you need, like what is your number? Like you say 1 through 10, and it will give you a number between 1 and 10, including 1 and 10. So that's how you make it random. So you can look at the biodiversity here. The other thing you can do is maybe you're just trying to track one species. So let's pretend that we only want to count, we want to know how many of these grasses can we find per square meter. So you randomly drop them 10 times, right? Oh, 10 is the minimum number that you should use. 10 samples, I recommend 15. I might push you to 15 if you're doing your IA, but 10 is the minimum. So if you've dropped 10 squares, you've dropped 10 quadrats, all randomly. I should be using a random generator, but I'm pretty lazy. For argument's sake, I'm only going to do 5. And then you count your blades of grass. In this one, looks like there's 0. In this one, it looks like there's 2. Here I have 1, 2 also. Here I have 1, and here I have 2. So 2 plus 2 plus 1 plus 2 is 7. And if I want to know how many blades of grass there are per square meter, I just divide it by the number of times I drop my squares, right? 5, although you should do 10. I drop 5 squares, so then I can determine that the average number of grasses per square is 1 point something. What is that, 1.4? I think so, right? So 1.4 blades of grass per square meter, according to this one. So that's another thing you can do if you're doing your IA, if you're just looking at an individual species.